Now, there are actually two compilers built into the Java virtual machine called C1 and C2. The C1 compiler is able to do the first three levels of compilation. Each is progressively more complex than the last one, and the C2 compiler can do the fourth level. The virtual machine decides which level of compilation to apply to a particular block of code based on how often it is being run and how complex or time-consuming it is, and this is called profiling the code. So for any method which has a number of 1 to 3, the code has been compiled using the C1 compiler, and the higher the number, the more profiled the code has been. If the code has been called enough times, then we reach level 4 and the C2 compiler has been used instead. And this means that our code is even more optimized than when it was compiled using the C1 compiler. And the Java virtual machine can actually decide, do you know what, this code is being used so much, not only am I going to compile it to level 4, I'm also going to put that compiled code into the code cache, the special area of memory, because that will be the quickest way for it to be accessible and therefore run. So the higher the level of compilation, and this is often called the compilation tier, the more optimized the compiled code should be. But the virtual machine doesn't just optimize everything to tier 4 because there is a trade-off. It only optimizes the most frequently called code, and if that code isn't doing anything complex, there may be no benefit from a deeper level of compilation, so it won't happen for that reason. But what we can see here in our example is that the isPrime method first got compiled at tier 3, and then a little bit later on, it got compiled at tier 4. The virtual machine determined that this method is running so much and is so important to our application that it needed to be compiled with the C2 compiler and then placed in the code cache for optimal performance. So the flag that we've just seen, print compilation, will output this information to the console. There is an alternative which will output to a file, and that gives a little bit more information, although it does need a bit of work to read through the output. But in case this is useful for you, and it could be useful if you're wanting to know what's happening on a remote machine where you can't see the console, what you do is, and actually I'll just type this in as we do it, we're going to use a flag called log compilation, but in order to use that, we actually need another flag first called unlock diagnostic VM options, and that flag must come first in the list. So what we're going to do is something like Java. We then want the first of our flags, which is -xx colon plus unlock diagnostic VM options. And again, these flags are case sensitive, so just make sure you get that exactly as I've typed it in here. The second flag then is -xx colon plus, and it's log compilation. And then we can have the name of the class that we're running, and we want 5,000 prime numbers. I'll press enter, let that run, and then if we look in our folder where we've been running it, we should see there is a file here that has been produced by running the Java virtual machine with this log compilation flag. I've opened up this text file in a text editor just to show you what it looks like, and actually if I search for isPrime, here we are, we can see that we have a queued task which is going to be to compile our isPrime method at level 3. And if I look for the next occurrence of isPrime, then actually here's the compilation going on using the C1 compiler to level 3 of isPrime. I'll search again, and this time we've got a compilation taking place of isPrime, and it's at level 4 using the C2 compiler. Now there's all sorts of other things output in here as well. If that's interesting to you, I'll leave you to look up what they mean. I don't think it's that important. At least we can see here in this example that our isPrime method was compiled to level 4 using the C2 compiler.